Hello and welcome to Sally and Bytes. Let's delve into the world of generative AI, exploring how it works and its incredible potential. So, buckle up and get ready to be amazed. Have you ever wondered how artificial intelligence can create stunning art? Compose music that stirs the soul, and even write captivating stories? That's right. All thanks to generative AI. Humans have a remarkable ability to think creatively, imagine new things, and express themselves through art, music, and language. We learn from our experiences, observe the world around us, and use our imagination to come up with new ideas. Artificial intelligence, AI, is like teaching computers to think and learn in ways similar to humans. It involves programming computers to perform tasks that normally require human intelligence, such as recognizing patterns, making decisions, understanding language, and solve problems on their own. Machine learning is a subset of AI that focuses on teaching computers to learn from data without being explicitly programmed. Through machine learning, computers can improve their performance on tasks by learning from examples and experience. Deep learning is a type of machine learning that uses artificial neural networks inspired by the human brain. These networks consist of layers of interconnected nodes that process data, enabling computers to recognize patterns and make predictions with high accuracy. So, what exactly is generative AI? Generative AI, sometimes called GenAI, takes artificial learning and deep learning to the next level by enabling computers to create new original content, such as images, text, video, audio, or software code, that is similar to what humans produce, in response to a user's prompt or request. It works by training algorithms on large datasets of examples, allowing computers to generate new and original content based on learned patterns. How does generative AI differ from other types of AI? Supervised and unsupervised learning. Generative AI differs from supervised and unsupervised learning. Supervised learning predicts or classifies using labeled data. This type of machine learning uses training data with known outputs, called labels. For example, a model trained to recognize dogs and cats uses images labeled as dog or cat to learn the difference. And unsupervised learning finds patterns in unlabeled data. Now we can see how generative AI works with images. Generative AI starts by looking at lots of pictures. For example, it learns the structure and characteristics by examining numerous images of cats and dogs to generate content similar to, but not identical to, the training data. After learning from these examples, the generative AI uses its knowledge to create new, original content with the help of computers and mathematics. It can generate new pictures that we have never seen before. Here, you can see a new picture of a dog and a cat. It's like having a smart computer that can make new things all by itself, without any help from humans. Let's understand generative AI better. What can generative AI create? Generative AI can create many types of content across many different domains. Images, music, audio, video, text, software code, design and art, simulations, and synthetic data. Let's see about the images. Generative AI can create images of people, animals, objects, and scenes that we have never seen before. It can be used for making new art, designing products, or creating realistic fake news images. Think of generative AI as a magic pen. Imagine this mystical pen writes, "Create a beautiful wonderland, with sparkling trails of stardust, bringing your wildest imaginings to life." It can create new things without any help from humans. It's like having a computer that can be creative. Now the magic pen writes, "Create a futuristic metropolis." What can you see here? Here's a glimpse of a futuristic metropolis that rises from the neon-lit canyons, where skyscrapers pierce the clouds and hovercars weave through the bustling streets. Generative AI isn't just copying what people do. It's making up brand new stuff that nobody has ever seen before. It's like magic, but with computers and mathematics. DALL-E, Midjourney, Runway ML, and Stable Diffusion create realistic images or original art. They perform style transfer, image-to-image translation, and image enhancement. Here is an example of how generative AI works. I type the text description, create images of a mystical forest, and then the magic happens, revealing the generated images of the mystical forest. Generative AI can create new music even if the user doesn't know how to play an instrument or read music. It can be used to compose songs, soundtracks, and music for video games. Similarly to image creation, we can also create music with generative AI. I type the text, compose a folk song about legendary adventures on the high seas, and generative AI composes lyrics along with the corresponding music and even generates an image to match. Let's listen to the music generated by AI.
In a land of dreams and tales untold, legends of old, the sailors unfold. With wind in their sails and courage untamed, they sail the high seas, their stories of fame.
Vav. It's so amazing. The lyrics really resonated with me. Such a beautiful song. Suno, MusicGen, TextFX are generative AI music tools. They compose original music across genres, catering to various creative needs and preferences. Generative AI, trained on annotated video, can create temporally coherent, detailed, and photorealistic video clips from text. For example, when we type the prompt, time-lapse of a common sunflower opening, dark background, you can see the video generated. Vav. It's so amazing. Notable examples of this technology include Sora by OpenAI, Gen 1 and Gen 2 by Runway, Make a Video by Meta Platforms, Pika Labs, and Google DeepMind. Generative AI can be used to create new pieces of text, such as poems, stories, or even code. This could be used to create new books and scripts, or even generate new ideas for businesses. One of the key advancements in generative AI has been the development of large language models, LLMs. These models, such as ChatGPT, have revolutionized our ability to understand and generate human-like text. They can produce coherent and contextually relevant language, pushing the boundaries of what AI can achieve in language-related tasks. For example, ChatGPT is a chatbot that uses generative AI to answer questions and provide information. You can ask it anything, from what is generative AI to what's the weather like today, and get a response that sounds like it was written by a human. ChatGPT has a wide range of uses across various fields and for different purposes. Customer support. Many companies use ChatGPT to provide instant customer support. It can answer common questions, help troubleshoot issues, and provide information about products and services. Content creation. Writers and marketers use ChatGPT to generate content ideas, write articles, create social media posts, and draft marketing copy. It helps streamline the content creation process and boosts creativity. Education. Students and teachers use ChatGPT for tutoring and educational support. It can explain complex topics, provide summaries, help with homework, and even create quizzes and study guides. Programming assistance. Developers use ChatGPT to get help with coding. It can write code snippets, debug errors, explain programming concepts, and suggest improvements to existing code. Language translation and learning. ChatGPT can translate text between different languages and help users learn new languages by providing practice exercises, grammar explanations, and conversation practice. Personal assistants. Individuals use ChatGPT as a personal assistant to manage schedules, set reminders, provide weather updates, recommend recipes, and more. Mental health support. Some applications use ChatGPT for providing mental health support by offering a listening ear, suggesting coping strategies, and directing users to professional resources. Entertainment. Users can engage with ChatGPT for entertainment purposes, such as playing text-based games, generating creative stories, telling jokes, or engaging in interesting conversations. Research. Researchers use ChatGPT to quickly gather information on various topics, summarize research papers, and generate hypotheses for further investigation. Business intelligence. Businesses use ChatGPT to analyze data, generate reports, and provide insights that can help in decision-making processes. Knowing how to write prompts correctly is the key to helping you use generative AIs. Simulations and synthetic data. Generative AI enhances simulations, such as using Unity to create realistic urban traffic scenarios for city planning, and produces synthetic data, like Tonic.ai, generating privacy-preserving synthetic customer data for retail analytics. Have you heard of animated drawings presented by Meta AI Research? It's really fun and really easy to use. You can bring children's drawings to life by animating characters to move around. You can upload any picture you want. It just needs to be on a white background with each limb separate and visible. This is one of my kids' drawing which came into life. You have a bunch of different animations to choose from. Let's see the second image. Wow! It's so fun and amazing. Let's see about generative AI in design and art. Digital art. Generative AI can create unique pieces of art by learning from vast datasets of images. Tools like DeepArt and Runway ML enable artists to explore new styles and concepts. Graphic design. AI-driven tools can assist designers by generating logos, layouts, and other graphical elements, speeding up the design process and offering new creative possibilities. Let's see the technologies behind generative AI. The types of AI models. Generative Adversarial Networks, or GAN for short, is a generative AI class that has recently gained much attention. The concept was initially developed by Ian Goodfellow and his colleagues in June 2014. They wanted to create a system to generate new samples similar to the original data. They came up with the idea of using two neural networks in competition with each other. GANs consist of two neural networks, a generator and a discriminator. We have already seen what exactly is neural network in my previous video, deep learning. A neural network is a computational model inspired by the human brain, consisting of interconnected nodes, neurons, that process and learn from data through adjustable weights and activation functions. Neural networks rely on training data to learn and improve their accuracy over time. The generator's job is to create realistic outputs that mimic the input data, while the discriminator's job is to identify whether the output is real or fake. For example, imagine you have two teams. One team bakes cookies and the other team tastes them to see if they taste like cookies from a famous bakery. In this analogy, the baking team is like the generator in a GAN, creating data, cookies, and the tasting team is like the discriminator, evaluating the data to see if it matches the desired standard. The baking team starts off making cookies that aren't quite right, and the tasting team easily spots the differences. The baking team keeps adjusting their recipe based on the feedback from the tasting team, and over time, their cookies start to taste more and more like the ones from the famous bakery. Meanwhile, the tasting team gets better at detecting even the smallest differences. Eventually, the baking team gets so good that their cookies are nearly indistinguishable from the famous bakery's cookies. GANs have been used for various applications, including image and video generation, text generation, and music composition. Autoencoders are another generative AI model. Autoencoders are neural networks trained to compress and reconstruct input data, such as images or text. This process of compression and reconstruction allows the autoencoder to learn a compressed representation of the input data that can then be used to generate new, similar data. How do autoencoders work? Imagine you have a very large and detailed picture of a cat, but you want to save it in a smaller file without losing too much detail. Autoencoders do this by having two main parts. Encoder, this part compresses the original data into a smaller, more manageable size. Decoder, this part takes the compressed data and tries to recreate the original data as closely as possible. Encoder, you then describe this cat using just a few key details. For example, it has pointy ears, big eyes, a small nose, and whiskers. Compressed information. Now, instead of having the whole picture, you just have this short description. Decoder, based on your short description, your friend tries to draw the cat again. The goal is that your friend's drawing looks as close as possible to your original drawing, even though they only had your short description to go on. If they can draw a cat that looks almost like your original one, your description, compression, and their drawing, reconstruction, process worked well. Why are autoencoders useful? Data compression. They help to reduce the amount of data that needs to be stored. Noise reduction. They can help clean up noisy data, making it more usable. Feature learning. They can automatically learn important features from the data, which can be useful for other tasks like classification or clustering. In essence, autoencoders help us understand and use large amounts of data more efficiently by learning how to keep only the most important parts and discard the rest. Autoencoders are a powerful tool for unsupervised learning and have numerous applications in various fields, including computer vision, natural language processing, and anomaly detection like credit card fraud detection. Variational autoencoders (VAEs) are a special kind of autoencoder that not only compresses data and then reconstructs it, but also learns a way to generate new data that looks similar to the original data. This makes VAEs useful for tasks like creating new images that look like they belong to the same set of images they were trained on. How do VAEs work? VAEs have three main parts. Encoder. This part compresses the original data into a smaller, more manageable size, but it also adds a bit of randomness to allow for generating new data. Latent space. This is the compressed representation of the data. It's like a map of the key features of the data, with some randomness added. Decoder. This part takes the compressed data from the latent space and tries to recreate the original data. Let's use an example of creating new drawings of cats. Original drawings. You have many detailed drawings of cats. Encoder. The VAE looks at these drawings and compresses each one into a simpler, smaller description. But instead of just one description, it creates a range of possible descriptions by adding some randomness. Latent space. Imagine this as a big map where each point represents a possible way a cat could look based on the drawings you have. Decoder. The VAE takes a point from this map, a compressed description, and uses it to create a new drawing of a cat. While a traditional autoencoder compresses an image to a fixed code and reconstructs it, a VAE encodes the image as a distribution and can generate new, similar images by sampling from this distribution. Transformers are a type of generative model used in machine learning, especially for understanding and generating human language. Imagine you have a really smart assistant that reads a lot of books and learns to understand the meaning of sentences, then uses that knowledge to answer questions or even write stories. Let's say you want to translate a sentence from English to Spanish. You give the sentence, "The cat is sleeping," to the transformer. It looks at each word, understands their meanings and relationships, and then transforms it into "El gato está durmiendo" in Spanish. Transformers are great at tasks like translation, summarization, and even chatbots because they can handle and process language in a very effective way, much like how we understand and use language in everyday life. How does generative AI work? Step 1: Training. To create a generative AI model, a large dataset is needed for the model to learn from. This dataset can be text, images, or any other data type the model will generate. Step 2: Pre-processing. Before the data is fed into the generative AI model, it must be pre-processed to make it easier for the model to understand. This can involve converting the data into a format that the model can work with, such as converting images into pixels or text into numerical vectors. Step 3: Model architecture. There are several generative AI models, each with its architecture. The most common type of generative AI model is a generative adversarial network, GAN, which consists of two neural networks, a generator and a discriminator. The generator creates new content based on the input it receives, while the discriminator evaluates the content and provides feedback to the generator. Step 4: Training the model. Once the model architecture is defined, the model is trained using the pre-processed data. During training, the generator creates new content based on random inputs, and the discriminator evaluates the content to determine if it is real or fake. The generator then adjusts its output based on the feedback from the discriminator until it can create indistinguishable content from the real data. Step 5: Generating new content. After training the model, it can generate new content based on its input. For example, a text-based generative AI model might be fed a sentence or a paragraph and then generate a new paragraph or story based on that input. Similarly, an image-based generative AI model might be fed an image and then generate a new similar image, but not identical to the original. Generative AI is used in various industries such as healthcare, retail, manufacturing, aerospace, defense, finance, software development, media and entertainment, advertisement and marketing. Generative AI enhances cybersecurity by simulating potential threats and identifying vulnerabilities, aiding in the development of effective countermeasures. It also creates realistic phishing simulations to train employees in recognizing and responding to phishing attempts. Ethical considerations of generative AI. Generative AI can produce fake news or deepfakes, manipulating images or videos to falsely portray actions or statements, spreading misinformation and damaging reputations. Generating harmful content. AI can create violent or hate speech content, promoting violence and discrimination. Malicious uses. AI can be exploited for malicious purposes, such as creating spam or hacking, necessitating awareness and mitigation of these risks. Let's see the career path. Educational preparation. Focus on key subjects. Mathematics. Excelling in subjects like calculus, linear algebra, probability, and statistics is crucial. These areas form the mathematical foundation for understanding algorithms and machine learning concepts. Computer science. Take any available courses in programming, data structures, algorithms, and computer science principles. Physics. Useful for developing analytical and problem-solving skills. Develop programming skills. Learn programming languages. Python. Start with Python due to its simplicity and extensive use in AI. You can also start learning Python from my YouTube channel, with easy and simple explanations and practical implementations. Other languages, basics of Java or C++, can also be beneficial. Explore AI and machine learning. Hands-on projects. Google Colab, an online platform to write and execute Python code with free access to GPUs. Kaggle, participate in beginner-friendly competitions and work on datasets. Self-directed learning and research. Books for beginners. Python Crash Course by Eric Mathis, a hands-on, project-based introduction to Python. Artificial Intelligence, a guide for thinking humans by Melanie Mitchell, a comprehensive introduction to AI concepts. Plan for higher education. Choosing the right college and major. Majors: computer science, data science, electrical engineering, or a related field with a focus on AI. Colleges: look for universities known for their strong computer science or engineering programs. Gain exposure to the field. Internships and summer programs. Stay updated and inspired. Follow AI news and trends. Thanks for watching. Please subscribe if you are new to my Sally and Bytes YouTube channel. Stay tuned for more insights and updates on the latest in AI technology. Share this video with your friends and relatives. You can check the link in the description box below.